Hello everyone, I'm Henry. Today I would like to present about the few effect on crystal structures for soldiers TiO2. So let us start with this paper, and this paper is basically discuss the effects by varying the acidic pH of soldier precursor solutions, and that will affect the TiO2 structures. And as a result, the wave guiding performance and the optical confinement will be changed as well. And for the first time, the authors present that the TiO2 at the same annual temperatures will be changed, the crystal structure will be changed with different pH values. As we can see, when the uh, acidity of TiO2 is stronger, the anodized structures will become stronger. We can see from the XRD patterns. And we all can also see the soldiers, so pH decrease, the crystal size will increase. And that means the higher acidities will promote the larger beta crystallized grain. The Figure 3 showed that the Raman's spectrums confine the pure anodized phase in all annuals TiO2 thin, and that will indicate that the solar acidities from pH from 6 to pH equals to pH 2 will collaborate the improved crystalline trend seen in XRD. The figure 4 shows that there's a ruins views from the figure 3 and emphasize on the peak at 144 and show that the source acidities increase, the peak become progressively narrow that will confining that will confine enhance crystalline qualities at lower pH. So as we see closer to the SEN's imagery and the particle size distributions, we can see when the acidity is increased, the thin surface will become denser or more uniform, and average particle size will grow. Just like consistent with the what we see in the XRD pattern. So also the AFN's photography's imagery also show that the roughness will progressively increased when the soil acidity is increased, and that will attribute to the larger grains uh, coalescence as higher acidity. So when we see the transparent spectrums from pH from 6 to more acid pH 2, the lower the soil pH slightly reduced transmittance due to the increased uh, grain growth and the surface scattering. So they also look into the bandwidth, the applicable bandgap values. It will revealing that the band gap decrease with the increase of soil acidity. And annually cause a significant overall band reductions due to the grain growth and the crystal value. And as we can see how the waveguide behaviors, we can see the increased soil acidity shift the mode dip to higher effective refractant index, increase refracting increased film density. And we can also look at the tables from the number. We can see uh, the grain the reflectance index of the TiO2 thin film will slightly reduce the direct optical band gap. And it also shows that higher acidities produce denser and more uh, anisotropic anodized film with stronger optical confinement potential when the salt acidity increase. So the conclusion is that acidities will increase the anodized 101 crystalline and acidity increase the critical size. The thin film denser and particle size will increase, surface roughness will be increased. And as to the opticals performance, when acidities increase, the transmittance will be decreased and bandgap will decrease. But on the other hand, um, the refractive index will increase. Thank you.